Welcome to our project on agricultural CO2, emission and climate change. In this presentation, we will explore the impact of agricultural CO2 emissions on our planet and discuss how our analysis can contribute to a greener future. Let's dive in. Our journey begins with a staggering revelation. Agricultural CO2 emissions account for a significant 62% of the global annual emissions. This makes understanding and addressing the environmental impact of the agri-food industry crucial for mitigating climate change and fostering sustainable practices. Data overview. Before delving into the analysis, let's take a look at our data. It encompasses essential features such as CO2 emissions, temperature, and urban population, providing valuable insights into their relationships and trends over the years. Data features. Here we'll examine the key features of our dataset, including the temporal aspect of emissions, the distribution of temperature, and the urban population's impact on CO2 emissions. Exploratory data analysis. Our exploratory data analysis is a window into the trends and patterns hidden within the data. We'll uncover fascinating insights by visualizing CO2 emissions, temperature variations, and urban population trends. CO2 emission over the years. Behold the captivating line chart showcasing the trends in CO2 emissions, temperature variations, and urban population over the years. It offers a holistic view of the changes and relationships between these critical factors. Correlation matrix. The correlation matrix unveils the interplay between CO2 emissions, temperature, and urban population. Understanding these correlations empowers us to create targeted strategies for sustainable development. Box plot. Average temperature. Each year. Our box plot graph depicts the distribution of average temperatures each year. It provides valuable insights into temperature variations over time, aiding us in understanding climate change trends. Scatter plot. CO2, emission and temperature, population. Behold the captivating scatter plot representing the relationship between CO2 emissions, temperature, and population. Top 31. Emitting countries in 2020. In 2020, the top 31 emitting countries contributed significantly to global CO2 emissions. Understanding their contributions is essential for targeted environmental policies and international cooperation. CO2. Emissions per capita. A breakdown of CO2 emissions per capita across countries gives us a deeper understanding of individual carbon footprints. It helps identify regions where sustainable practices can create a profound impact. Total global CO2 emissions in 2020. Let's take a moment to grasp the enormity of the total CO2 emissions worldwide in 2020. This staggering figure reinforces the urgency to combat climate change. Model development. Moving on to the development of our predictive model. We evaluated 5 powerful algorithms: linear regression, random forest, decision tree, support vector machine, SVM, and gradient boosting, to find the best fit for our data. Model evaluation. After a thorough evaluation, the random forest regressor emerged as our best performing model. Its high R-squared value of 0.97 indicates its ability to accurately predict temperature variations. Solutions for a greener tomorrow. Armed with insights from our analysis, we propose actionable solutions for a greener future. By promoting sustainable agricultural practices, we can significantly reduce CO2 emissions and pave the way for a more sustainable world. Unveiling the temperature and emission trends. Our analysis uncovers crucial temperature and emission trends that impact our planet's climate. By identifying these trends, we can implement targeted strategies to mitigate climate change. Population impact on emission. Understanding. The impact of urban population growth on CO2 emissions is vital. By incorporating population dynamics into our solutions, we can address the environmental challenges arising from urbanization. The power of predictive modeling. Leveraging. Predictive modeling enables us to anticipate temperature variations and their implications for CO2 emissions. By harnessing data-driven solutions, we can better prepare for a greener future. Conclusion. In conclusion, our project on agricultural CO2, emission and climate change reveals the vital role of the agri-food industry in global emissions. By understanding the impact and leveraging advanced modeling techniques, we can pave the way for a sustainable and greener future. Emission trends. Over the years, through our analysis, we have unraveled the increasing trend of CO2 emissions over the years. The data reinforces the urgency to adopt sustainable practices and combat climate change. The relationship between emissions, temperature, and urban population. Our findings demonstrate the intricate relationship between CO2 emissions, temperature variations, and urban population growth. By addressing these connections, we can implement targeted strategies for environmental sustainability. Together, towards a greener future. Narrator. Together, we can make a difference by leveraging data-driven solutions to create a positive impact on our planet. Let's work hand in hand towards a greener and more sustainable future. For this project, we relied on reputable sources such as the Food and Agriculture Organization, FAO, Intergovernmental Panel on Climate Change, IPCC, and World Resources Institute, WRI. The complete list of references can be found on our GitHub repository. The end. Thank you for joining us on this journey towards a more sustainable tomorrow. Let's continue making a positive impact on our planet. Together, we can build a greener world for future generations.